So let's define what a complex number is. Complex numbers. So these involve I, which the square root of -1 is I. So we're dealing with square roots of -1. So you should be kind of familiar with how to work with those. Now let's talk about how to work with a complex number. So when we put the I part together with a real part, it's going to look like this, A plus BI. So this is how we define a complex number. A is the real part, and BI is the imaginary part. So up to now, you know, you've been in math all the time, you've been working with complex numbers, but it's just been when B has been 0. Okay, so far, probably everything you've known, unless you've dealt with imaginary numbers before, is that when a complex number when B is 0. That part's gone, just the real part, when we talk about real numbers. So now we're throwing in more to that, the other half of that, the imaginary part of numbers too. So let's now talk about how to work with these as we see what they look like. So let's do some adding and subtracting ones. Let's say I've got 6 plus 2i. So that is a complex number. 6 is the real part, 2i is the imaginary part. So I'm putting in parentheses, emphasize this is one of the real numbers. And then I add it to -3 plus 4i. Okay, so this complex number plus this complex number. So with adding them, we treat I just kind of like x. So we don't really need these parentheses anymore. I'm just going to rewrite it, dropping them. And just combine like terms. 6 and -3 or -3 is 3. 2i plus 4i is plus 6i. So it combines to the complex number 3 plus 6i. Okay, or how about 4i minus 5 minus 2i. So here, with subtraction, we need to subtract both parts. So it's going to be a -5 and a plus 2i. So it's like we're distributing. Okay, so even though these aren't variables, we treat the I like an x. All the different rules of x, dealing with x's apply. So just combine that to -5 plus 6i. Okay, now how about a multiply one? Let's do 4 plus I times 3 minus 2i. So we've got a complex number times another complex number. So let's FOIL it out. 12 minus 8i plus 3i minus 2i squared. So now, let's do a little simplifying, bring the 12 down. I can combine the i's to be minus 5i. Now here, remember, I squared is -1. If I square both sides, I get I squared is -1. So this is -2 times -1, so that becomes a plus 2. So 12 plus 2, 14, minus 5i. Okay, how about, let's do another one. How about just 3i times 5 plus 6i? So this is still a complex number, just that the real part is 0. So this one's just a matter of distributing. 15i plus 18i squared. But I wouldn't leave it like that because I can simplify I squared as -1. So this will be a -18. I'm going to put the real part first and then plus 15i, the imaginary part, second. That's kind of how we always denote it, just like when I defined it. One more multiply one, which is going to lead us into dividing. How about 5 plus I times 5 minus I? So 25 minus 5i plus 5i minus I squared. So the middle two are going to drop out. Minus I squared, this is going to be a minus a -1. So now I'm going to have 25 plus 1 is 26. So notice the I imaginary part drops out. All I'm left with is the real part. So keep that in mind as we do division now. And look at these. What these are called is complex conjugates. So as long as it's the same value here, 1's plus 1 is minus, it's called the conjugate. And we would always use that if we want the imaginary part to drop out. Same idea with rationalizing denominators with roots. You do the conjugate, because then the outer and the inner are going to drop out, the part I don't want. Okay. So with dividing, we're going to make a little definition here. With dividing, we're going to multiply the denominator by the complex conjugate. And what the complex conjugate is if you have a plus bi, it would be a minus bi, and vice versa. If you have a minus bi, you would multiply by a plus bi. So, if I have 3 plus 4i divided by 6 minus I. Okay, so, because the goal is I want to take this divided by this, which means I want to combine them, so the way I do that is by multiplying by, in this case, it's 6 minus I on the bottom, so I'm going to multiply by 6 plus I. So, I have to do the same thing on top now. Okay, so on top, I will have 18 plus 3i plus 24i plus 4i squared. And let's just keep working on the top for a minute. So 18 plus 27i, this will be a minus 4. Let's just combine that right away. So I've got a positive 18, this will become a minus 4. So 14 plus 27i. Now to the bottom. So 36, first, outer plus 6i, inner minus 6i, last minus I squared. So that the 6i's cancel out, which is what I wanted. So I'm going to have 36. This will turn into a plus 1. So 37 on the bottom. So, and to really emphasize that now this is just one combined number, that would be 14 37ths plus 27 37ths I. Now that is one combined complex number from dividing these two different ones.